So we're still dealing with our same buffer solution with ammonia and ammonium, NH4+, but this time instead of adding base, we're going to add acid. So we add 0.03 moles of HCl, and let's just pretend like the total volume is 0.50 liters. And our goal is to calculate the pH of the final solution here. So the first thing we could do is calculate the concentration of HCl, right? So that would be moles over liters. So that's 0.03 moles divided by our total volume of 0.50 liters. And 0.03 divided by 0.5 gives us 0.06 molar, right? That's our concentration of HCl. And HCl is a strong acid, so you could think about it as being H plus and Cl minus. And since this is all in water, H plus and H2O would give you H3O plus, or hydronium. So 0.06 molar is really the concentration of hydronium ions in solution. And so the acid that we add is going to react with the base that's present in our buffer solution. So this time our base is going to react, and our base is of course ammonia. So let's write out the reaction between ammonia, NH3, and then we have hydronium ions in solution, H3O+. Alright, so this reaction goes to completion, and if ammonia picks up a proton, it turns into ammonium, NH4+. And if H3O+ donates a proton, we're left with H2O. So we write H2O over here. All right, for our concentrations, right, we're going to have 0.06 molar for our concentration of hydronium ions, so 0.06 molar. And the concentration of ammonia is 0.24 to start out with. So we have 0.24. And for ammonium, it's 0.20. So we write 0.20 here. So all of the hydronium ion is going to react. So we're going to lose all of it, right? So we're left with nothing after it all reacts. So it's the same thing for ammonia, right? So that we're going to lose the exact same concentration of ammonia here. So we're going to lose 0.06 molar of ammonia because this is reacting with H3O+. And so after neutralization, right, we're left with 0.18 molar for the concentration of ammonia. And whatever we lose for ammonia, we gain for ammonium, since ammonia turns into ammonium. So we're going to gain 0.06 molar for our concentration of ammonium after neutralization. So we get 0.26 for our concentration. And now we're ready to use the Henderson-Hasselbalch equation to calculate the final pH. So let's do that. All right, get some more space down here. So the pH is equal to the pKa, which again we've already calculated in the first problem, is 9.25, plus the log of the concentration of the base, right, and that's 0.18, so we put 0.18 here, divided by the concentration of the acid, which is NH4+, so that's 0.26. So 0.26, and we go ahead and take out the calculator and we plug that in. So log of 0.18 divided by 0.26 is equal to negative 0.16. Right, so let's go ahead and write that out here. So we have our pH is equal to 9.25 minus 0.16. And so that comes out to 9.09. So the pH is equal to 9.09. So remember, for our original buffer solution, we had a pH of 9.33. So we added a lot of acid. The pH went down a little bit, but not an extremely large amount. So once again, our buffer solution is able to resist drastic changes in pH.